തുടങ്ങിയാലോ? ഹലോ, കേൾക്കുന്നുണ്ടോ? ഓക്കെ, ഞാൻ ഇത് റെക്കോർഡ് ചെയ്യുന്നുണ്ട്. അപ്പോൾ ഈ ക്ലാസ് തന്നെയായിരിക്കും ഞാൻ നിങ്ങൾക്ക് അയച്ചു തരാം കേട്ടോ, വേറെ എഴുതിയിട്ടില്ല. സോ ഇൻ ദിസ് semester we are discussing testing of hypothesis. Okay, we know that in statistical distributions we have plenty of distributions available in literature. You know, normal distribution, Bernoulli distribution, binomial distribution, hypergeometric distribution, Poisson distribution, normal distribution, distribution, Poisson distribution, etc. So in all these distributions, you can see some unknown parameters. For example, in normal distribution, what are the unknown parameters? What are the unknown parameters? In the case of normal distribution, what are the unknown parameters? Mean mu and variance sigma square. Okay. In binomial distribution, what is the unknown parameter? P is the unknown parameter. So we have, these are some examples of several distributions. So in discrete and as well as in continuous distributions, we have distributions, and in that distribution we will have some unknown parameters. Okay, in the case of normal distribution, the unknown parameters are mu and sigma. So we have to know the value of the mu and sigma for the probability calculation. Okay, in order to calculate the probabilities using distribution, we have to know the value of the parameters. Okay, sometimes the population may be very large. It may we may not be able to collect all the information from all the data, all the individuals, all the units of the population. So in that case, we will select samples. Suppose a study is based on some behavior of people of Kerala. So what we have to do? We have to collect data on that behavior from each and every individual of the people living in Kerala. So, but it is practically difficult. So in that case, we will select some samples. From each district, we will select some 100 samples. And from that sample, we will estimate, calculate some estimate values for the mean and variance. Okay, or for the unknown parameters. So in order to find out the values of the unknown parameters, for example, in order to find out the value of mu and sigma in the case of normal distribution, we have to we have to take all the observation of the population, but it is sometimes it is not possible. So we will select the sample and we will use sample mean and sample variance instead of population mu and population variance. So the theoretical development of using sample version of the population parameters, that theory is discussed in the theory of estimation. Okay, so in the estimation theory, we will discuss the procedure of finding some suitable estimators based on the sample for the population parameters. So we will consider, now we can consider, look at this figure, look at this page. Let x1, x2, xn be a random sample from the population having distribution function f theta. F theta means distribution function of the population under consideration, where the functional form f theta is known except for the parameter. theta may be unknown. Theta may be population mean, or theta may be population variance. For example, in the case of normal distribution, here theta is actually population mean. So when we take sample observation, we will not get the population mean. If we want to find out the population mean, we have to select all the information in the population and add and divide by total number. So that is not practically possible. So in that case, we will take the samples and we will estimate the theta based on this sample. Okay. So here theta is unknown. Theta is not known. Okay. So another example is given here. Consider a coin tossing experiment. Okay. So the parameter is the unknown value is only P. Okay. Probability of success. Okay. You know that P lies between 0 and 1. P lies between 0 and 1. So we have to select a sample and estimate the value of P based on that sample. Okay. The statistical theory claims that by using this type of estimation procedure, we will get almost accurate result as we get in the population analysis. Okay. So in this case, P is the unknown parameter. So these are usually known as parameters. The unknown quantity of interest of some populations are usually called as parameters. So definitions are clearly given here. So I am not writing, and example is given here. Yeah, in a coin tossing experience, one frequently assumes that the coin is fair. So what is the need of testing of hypothesis? Yeah, when we consider some assumption about the population, for example, let us look at this example. In a coin tossing experience, one frequently assumes that a coin is fair. That means it is unbiased. That means the probability of getting head is equal to 1 by 2 and probability of getting tail is 1 by 2. That means fair. So we assume that the coin is fair. So we have to verify whether this is fair or not. Okay. How does one test whether the coin is fair? This is our assumption. Coin is fair is our assumption. How can we test? Okay. Or it is biased or unbiased. So one need to consider this procedure. That means a reasonable procedure would be to toss the coin 10 times or 20 times or 50 times or 100 times and count the number of heads. If the number of heads occurred for the 10 tosses is 5, we can say that the coin would be biased. 5 by 10, it is 1 by 2. Okay, if we toss the coin 100 times, and if we get the number of heads 51, so 51 by 100 is almost equal to 1 by 2, so that we can claim that we can ensure that the coin is unbiased. So if the proportion of heads observed does not deviate too much from P equal 1 by 2, one would tend to conclude that coin is fair. So this is the testing procedure. A researcher is claiming the probability or claiming some assumptions, and we have to test whether this claim is true or not. If the proportion is almost close to 1 by 2, we can say that the claim is correct. Okay. So another example is given here. It is usual to manufacturers to take quantitative assertions about their products. For example, a manufacturer of 12-volt batteries may claim that a certain brand of his batteries lasts for capital N hours. So his claim is 100 hours or 1000 hours. We can see that in Philips company, it is 1000 hours. Okay, their life length, they are providing the warranty for 100 hours. Okay. So a manufacturer of 12-volt batteries may claim that a certain brand of his batteries lasts for N hours. How does one go about checking the truth of this assertion? How does one go about checking this truth of this assertion? We have to check. They are claiming, company is claiming, we have to check. So we have to select a sample. A reasonable procedure suggests that take a random sample of N batteries, okay, of brand in question, and note their life length of under more or less identical conditions. We can take some 10 number of light bodies, and we can, what is that, we can search for the record the life length of under more or less identical conditions. If the average length of life is much smaller than n, if we eh? Suppose we have put 10 bulbs on test, and suppose the life length observed are 500, 600, 700 hours in hours, 400, 500, 600, etc. Around 500. The company claims that 1000 hours, and our observation reveals that it is all and around 500. So it is much deviated from 1000. Okay, so it is, so we can reject the claim. That means we can reject. If the observations are on and around 1000, that means someone is 900, 950, 1000, 1550, 1100, etc. If the observations, if the 10 observations are in around 1000, we can accept that assumption. Companies claim, we can accept. Yes, company says correctly. It is almost 1000 hours. Okay, so we can put some bulbs on test and record the life length and take the average. If the average of that life length are almost close to 1000, we can say that the company claim is correct. So we can accept that. So we can purchase more and more bulb from that company. So that is the idea. Okay. So these two examples reveals several concepts. That means we have to test the claim. We have to test the claim using some observations. Okay, the claim may be what is that? Based claim may be for some parameters, or claim may be for some length of interval, or claim may be depend upon some unknown constants. So we have to check the claim based on the observations or random sample taken from some what is that, test. Okay, so that is the procedure. So we have to test the claim. We have to test the parameter value, whether this is correct. Is it correct or not? Can we accept or not? It is unbiased or biased, etc. So that type of procedures are involved in testing of hypothesis. Okay. So the parametric testing of, there are two types of testing of hypothesis: parametric testing of hypothesis and non-parametric testing of hypothesis. In parametric testing of hypothesis, we are considering the testing of parameters in distributions. Okay, when we discuss non-parametric section, we will discuss in detail the non-parametric testing. So here we are discussing only parametric testing of hypothesis. Okay, so in parametric testing of hypothesis, we are testing some value of parameters based on the random sample taken from the population, not based on the entire population. It is only based on the random sample taken from the population. Okay, so that is the procedure of testing of hypothesis, parametric testing of hypothesis. I think you are clear with this discussion of based on these two examples. Okay. Now we are moving to the mathematical formulation of these ideas. Okay. Here we are considering n random samples, x1, x2, etc., xn. That is samples taken from the population having distribution f theta. For example, we are considering height of the students. So each and every individual are considered as the unit of the population. So suppose we are recording, the height of Alina is 5.5, height of Ardra 5.6, height of Buana 5.4, height of Femi 5, Gobika, and so these are observations. So we can take some example. For example, x1 is Ardra TK. So height of Ardra TK is the x1 value. Next, I have taken randomly Gobika Biju. So Gobika Biju's height, that is x2 X2 is global gravity. Another sample when we take, I obtained Joffin. The height of Joffin is x3, and so on. We can take some finite numbers. So I'm not taking all the observations. I'm taking only some examples, and we are recording that observations. So that is usually denoted as x1, x2, x3, xn. Okay. So x1, x2, xn is the distribution of your group is distribution of height of your group is f theta. It may be normal distribution or by exponential distribution, etc. If it is normal distribution, theta will consist of two parameters. That is, one is mu and another is sigma square. If it is exponential distribution, there is only one parameter, lambda. So usually we are denoting the bold theta means it's a vector. Bold theta means theta 1 comma theta 2. Sometimes it is mu comma sigma. Okay, I will show you. So some theta. Okay, so you are you are representing theta equal to some one is mu comma another is sigma cap. So sometimes we may represent vector also in this is actually bold. Okay, so bold theta means it's a vector of parameters mu comma sigma that are unknown constants. Okay, so a parametric hypothesis we will have. In a parametric hypothesis we will have like unbiased or biased. You know, here we have in example 1 we have used unbiased or biased. So unbiased means, what is unbiased means? It is equivalent to P equal to 1 by 2. Okay, unbiased is equivalent to P is 1 by 2. When P is 1 by 2, that means equal probability for obtaining head and tail in a trial. Okay, so the coin will be unbiased. So biased means, what is biased? So so unbiased is equivalent to what is that? Unbiased is equivalent to yes, that implies unbiased implies P equal to 1 by 2. Okay, another claim is or biased. How can you say that? How can we represent unbiased? Biased, that is equivalent to P not equal to 1 by 2. Okay, 1 by 2. So in the case of unbiased, it is P equal to 1 by 2. In the case of biased, it is P not equal